everybody. Welcome to the day 9 video material. Today we're going to spend a little bit more time talking about normal probabilities and calculations. First thing we want to do is let's look at some definitions. The first definition we want to look at is the total area under any density curve, and they mean normal curve, is equal to 1. Okay? Or 100%. Okay, so either one. Now today we're going to specifically focus on a percentile. So let's look at the definition for that. So a percentile is the nth percentile is the smallest score that is greater than or equal to a certain percentage. Of scores. Okay, so let's think about that in terms of percentiles you've seen, like on the PSAT. So if you were in the 85th percentile, that would mean you scored better than 85% of everyone else. So your score would be the smallest score that was greater than or equal to 85%. So that's the way you want to think about it. Very easy to work with. Just try and relate it back to stuff you've seen before. Okay, so general normal definition kind of stuff. All normal distributions have the same overall shape. They're all bell curves. The exact density curve for a particular normal distribution is given by its mean. That's the Greek symbol right there, mu. Now, when we do this on the calculator, we often use x bar. And standard deviation, that's a Greek lowercase letter sigma. Now, the mean is always located at the center or middle of a symmetric curve and is the same as the median. So when you're talking about a perfectly symmetric curve, the mean and the median always have to be equal. Now, if you change the center, also known as mu, without changing your standard deviation, which is sigma, that's going to move your normal curve along the horizontal axis, and it's not going to change its spread. So you just imagine that if I were to give a curve to every single person in the class of 5 points on the last test, your grade relative to the person sitting next to you would not change. So standard deviation measures your score relative to somebody else. Now, our standard deviation controls the spread or variability of a normal curve. Here's what I mean, is down below, you have two exactly the same normal curves with one exception. The standard deviation is larger versus smaller. So if the mean is the same, both mu, but I change the spread, then you can make a wider, flatter distribution or a taller, skinnier. Both have 100%. So both equal 100% or 1. So up here, remember we said the total area was 1 or 100%. All right, now we have something called the empirical rule. We talked about that a little earlier on day 1. Let's go into more detail with our empirical rule. Our empirical rule says approximately 68% of all of our data is within 1 standard deviation, so plus or minus 1 sigma of the mean mu. Okay, so here's what I mean, is that if you look on this graph, going from -1 to +1, there's supposed to be 68% of the data. The next part, it's the 95% of the rule. That's supposed to be within 2 standard deviations of the mean. And what I mean by that is anywhere between +2 and -2 is supposed to be 95%. Okay, next we have our last one, which is the 99.7, and that's supposed to be plus or minus 3 standard deviations of the mean. So that's from -3 to +3 is supposed to have that much of the data. Now, hopefully that makes a little bit of sense because hopefully you saw this last year a little bit. Let's try some problems out with it to see how you feel about it. Okay, so I've already drawn your curve over here for you. Let's take a look at it and let's find some percentages, and we're not going to use z-scores. We're going to try using the empirical rule. So if I'm doing the empirical rule, here's what I know. There's supposed to be 68% of the data in these two. So if I pick up my calculator and I type in 68 divided by 2, I get 34% and 34%. Now, our next two are supposed to contain 95% of the data. So the way I handle that is I take 95 and I subtract 34 and 34, and then I divide that by 2, and that tells me there is 13.5% of the data here and 13.5. Now, I'm not going to write the little percentages once we get farther out just because it gets harder to write them. Then I'm going to go out 3 standard deviations. That's supposed to be 99.7. So I'm going to take 99.7 and I'm going to subtract the 13.5, the 34, the 34, and the 13.5. That's going to give me 4.7, which I will then divide by 2. That tells me that in this little area right here, there is 2.35% and 2.35%. So what about the rest of the curve? So if I take 100 and I subtract 99.7 and I divide that by 2, that leaves me with, way out here in this tail, 0.15 and 0.15. So if I'm looking at the information I have up here, let's try and label this out. My mean is 69. Just to remind you, you're going to take 69 and you're going to add 2.5, add another 2.5, add another 2.5, and that tells you that the scores that go under here are 71.5, 74, 76.5. Going the other way, 69 minus 2.5, minus 2.5, and minus 2.5 tells you that this number is 66.5. That one is 64. The one over here is 61.5. Now, all of these percentages will hold for the whole thing. So using my sketch from number 1, what percentage of men are taller than 74? Well, that's 74, and I want taller, so that's that direction. So all I need to do is take 2.35 and add 0.15 to that, and I'll end up with 2.5%. Yes, it's just that simple. What are the heights for the middle 95%? Well, using the empirical rule, I know that that's supposed to be 64 to 74. So 64 inches to 74 inches. What percentage of men are shorter than 66.5? Okay, so that's that line on the curve right there. And I know that what I need to do is add up 0.15 plus 2.35 plus 13.5. If I add all of that up together, 0.15 plus 2.35 plus 13.5, I will get 16%. Yes, it's just that easy. All right, 71.5 inches. Okay, so that is right here. corresponds to what percentile? So I need all of that area to the left. So that is 0.15 plus 2.35 plus 13.5 plus 34 plus 34. And I just need to add all that up. And I get 84% or 84th percentile. See, that wasn't bad at all. So let's take a look at, see how I did on that one. Oh, looks like there's one more to do. This one is bags of potato chips. Okay, so just like we did last time, I'm gonna start by breaking out my percentages. By the way, these percentages are not gonna change because it's a rule. So that's gonna be 34, that's gonna be 34. That's gonna be 13.5. This is gonna be 13.5. That's gonna be 2.5. This is gonna be 2.5. That's gonna be 0.15. And that's gonna be 0.15. Okay, that's never gonna change. Now let's put on our potato chip information. 9.12 is the number that goes there. Now I need the other numbers. So I'm gonna say 9.12 plus 0.15 plus 0.15 plus 0.15. So let's see, this spot will be 9.27. That's 9.42. That's 9.57. Okay, going the other way. 9.12 minus 0.15 minus 0.15 minus 0.15. So I've got 8.97, 8.82, and 8.67. So there's my sketch. So I'd like to know what percentage of bags, what's the percentile that goes with 8.97? Okay, so percentiles area that way. So that's going to be 0.15 plus 2.5 plus 13.5. Okay, so again, we're going to reach for our calculator. 0.15 plus 2.5 plus 13.5. Looks like we are going to have me not typing it in right. 3.5, 3.5. What a silly mistake. 3.5. So 16%. All right, now I'd like to know what percentage of bags are between 8.67 and 9.27. Okay, 9.27 actually. So let's see here. That will be 2.35 plus 13.5 plus 34 plus 34. So if I add all of those up, I should have my right answer. So 2.35 plus 13.5 plus 34 plus 34. So that is 83.85% of bags. Upward percentile, you can also write that as 16th percentile. As you can see, day 9, pretty easy, and it should be pretty quick. Again, if you have any questions, make sure you send me an email.